Dear students, last class we have started with decision tree learning algorithm, ID3 algorithm. We have seen the algorithm, and using that ID3 algorithm, the decision tree is constructed. So, not to construct the decision tree, that how the decision tree is constructed from means it will start from root. From root, it moves towards the leaf node. So, how we can identify that root node means using information gain. So in order to find out the information gain, we need to measure the entropy. So what is the purpose of entropy means it is used to measure the impurity of the training examples. Okay, so now we'll see what is mean by entropy and information gain in this class, the part of decision tree learning algorithm. Okay, so this is the entropy formula. Entropy of S is equal to minus P plus P log 2 P plus minus P minus log 2 P minus. P pi plus is the proportion of positive examples. P minus is the proportion of negative examples. Okay, so this we have taken. Here there are 5 negative examples and remaining 9 are positive. So how we can represent this entropy means entropy of 9 plus 5 minus, that is equal to minus 9 by 14 log 2 9 by 14 minus negative is 5 by 14 log 2 5 by 14. So we are getting the value 0.940. Okay, this is the entropy, general entropy of S. Okay, so from this we can measure the homogeneity of examples. How means the entropy is equal to 0 means, what is the meaning? If it is equal to 0 means all the members belongs to the same class, either positive or negative. Okay, if their entropy is going to take the value either 0 or 1 or in between 0 and 1. If entropy is taking the value 0 means all members of S belongs to the same class. That means all training examples belongs to either positive or it may be negative. If entropy equal to 1 means, meaning is it contains equal number of positive training examples and equal number of negative training examples. That is the meaning. If the collection contains unequal number of positive and negative training examples, then the entropy lies between 0 and 1. So this is the thing. This we have represented with the diagram. See here. So function is related to the Boolean classification. So that is P plus. Okay, P plus, and then this will be there. So positive examples. Varies positive examples are P plus means positive examples varies between with 0 and 1. It starts with 0 and between 1, 0 and 1. Okay, this is the entropy representation. So this is the values 0 to 1. This is the entropy lies between 0 and 1. Okay, so the information gain, how we can calculate means the information gain of S comma A. S is the general attribute, then A is the with respect to particular attribute. Okay, so there how we can give gain of S comma A is equal to entropy of S minus summation of V belongs to values of A, SV divided modulus of SV divided by S, entropy of SV. So where values of A is the set of all possible values for attribute A. A may take any number of possible values. Suppose for example here we'll take outlook. It takes the possible values sunny, overcast, rain. Okay, 3 possible values it is taking. And if we'll take temperature, it is taking the 3 possible hot, mild and cool, 3 possible values it is taking. So that is based on that thing it will be calculated. So for example, if you will take wind, values of wind equal to, it takes 2 values either weak or strong. Then S is equal to, already we have seen there are 9 positive and 5 negative examples. Then S weak, weak means, okay, so how many are weak in that thing? So we can find out in that. So how many attributes are taking that weak as positive and negative? So here we'll take wind. How many instances are taking wind value as weak for positive and negative? So weak will take wind value 1 negative, 2 negative, 2 negative training examples. The wind takes a weak value, and for 1, 2, 3, 4, 5, so 5, 6 positive examples. Wind took a weak positive, weak value. See here. That is 6 plus positive is 6 and negative is 2. And strong also same thing. Positive, in the positive 3 positive training example took the strong value and 3 negative training example took the strong as a wind value. Okay. So then how we can calculate means gain S comma wind is equal to entropy of S minus this one weak comma strong, because that one attribute we had taken a wind, it took two values weak comma strong, SV by S small entropy of SV, then entropy of S minus, then 8 by 14. Okay, so that 8 by 14 how it will come, that is a yes weak value. How many attributes are taking, how many instances, 6 plus 2 8 by total is 14, entropy of S weak minus, then in that how many positive this is taking strong value, then 6 by 14 entropy of S strong. Then we'll find out that entropy, we are getting this value. Finally we are getting that gain as information gain as 0.048. Okay, so then which attribute is the best classifier means, so here humidity, it is getting that value, this one humidity 0.151, S comma humidity, S comma wind is 0.048. So compared to these two information gain values, humidity and wind, the humidity value is more, that is 0.151. Okay, so that will be the most dominating node or best attribute. Humidity will be the best attribute. So that will be taken first. Okay. So like this way the entropy and information gain will be used. So this is for first step. Then next step again we have to apply among the remaining attributes entropy and information gain. We have to find out the most dominating node in the next level and so on. Okay. So take this formula, apply for the given training example and construct the decision tree. Okay, this is your homework, you can do it. Once you will do that, you will get confidence. This method is very easy. So ID3 algorithm you are going to implement in your lab using Python. Okay, Python language. Thank you.